Yeah, hello children. I'm sure you have gone through those all formulas and you are practicing every day. Now let us come to the new concept, very interesting concept called as angle between the circles. Right? Now, let us first assume that circles are intersecting. Right? If they intersect, it's only then the angle will come. If one circle is here, one circle is here, where is the angle? They have to come together, is it not? So, if two circles are intersecting, then I draw a tangent at the point of intersection of this circle and I draw a tangent at the point of intersection of this circle. Now when these two tangents are drawn, the angle between these tangents is called the angle between circles. So how do I define? I define, you may note it down, pen and paper should be there with you. The angle between the circles is defined as the angle between the tangents drawn at their points of intersections, right? So this is called angle between the circles. Now, what is the formula? If theta is the angle between, if theta is the angle between two circles with radii r1 and r2, then theta is equal to cos inverse d square minus r1 square minus r2 square by 2r1 r2. This is a formula, right? So this is a formula to determine the angle between the two circles. Alright, now there might be possible that this angle is 90 degrees. Let us see what happens if theta is 90 degrees. If theta is 90 degrees, what happens? Let us say I will write this as cos theta is equal to d square minus r1 square minus r2 square by 2r1 r2. Instead of theta, how much I have to put? 90. What is cos 90? Cos 90 is 0. So 0 is equal to d square minus r1 square minus r2 square by 2r1 r2. Cross multiply. What will you get? D square minus r1 square minus r2 square is equal to 0. Ultimately, I will get d square is equal to r1 square plus r2 square. So please remember, whenever the angle between the two circles is 90 degrees, then the condition you will remember is d square is equal to r1 square plus r2 square. Also, when the angle is 90 degrees, the circles are called as orthogonal circles. What are they called as? Orthogonal circles. Now this formula is applied taking d, r1 and r2 in consideration. Let us say if you are having x square plus y square plus 2gx plus 2fy plus c is equal to 0 is the first circle, x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0 is the second circle. If these two circles are given in this format, and if I say circles are orthogonal, right? If this circle and this circle are orthogonal to each other, orthogonal means you know the angle is 90 degrees, are orthogonal to each other, then condition is 2g(g1) plus 2f(f1) is equal to c plus c1. Very important condition. Most of the time long answer questions will be based in entrance examinations, also questions will be based. The condition is 2g(g1) plus 2f(f1) is equal to c plus c1 is the condition if two circles are orthogonal to each other. So I want you to pause the video and copy this. Meanwhile, we'll go for the next concept. Note. Now a very important concept. In your straight lines also you had this called as pencil of lines. In your straight lines, if there are two lines, then this point is called point of intersection. If two lines pass through a single point, it is called point of intersection. If more than two lines pass through this point, then this point of intersection will get a promotion and it is called as point of concurrence. The same point will be called as point of concurrence. So if L1 is equal to 0 is a line and L2 is equal to 0 is another line, and you desire to find some other line which is passing through this point of intersection of L1 and L2, then it will be of the form L1 plus lambda L2 is equal to 0. Is it not? In your first year geometry, you have come across this condition. The equation of any line passing through point of intersection of L1 is equal to 0 and L2 is equal to 0 is L1 plus lambda L2 is equal to 0, where lambda is a parameter. Means for different values of lambda, you will get different lines. This is what you have done. In a similar fashion, you are going to have a concept, because you may get a 7 marks question based on this. If there is a circle S is equal to 0 and there is a line L is equal to 0. A circle is being cut by a line in two distinct points, and How many circles will pass through these 2 points? See, this is one circle. Like that I can draw imaginary circles passing through 2 points. So what will I write? I'll write the equation of any circle passing through point of intersection of S is equal to 0 and L is equal to 0. S is equal to 0 is circle and line L is equal to 0 is line, is S plus lambda L is equal to 0. So you have to remember this, because tomorrow he may say find the equation of a circle passing through some x square plus y square so and so, and passing through some line and passing through the point of intersection of that and a point. So in order to get the value of lambda, you will substitute that point, you will get the value of lambda, substitute lambda equation back into this, and you will get the equation of the required circle. So this is very, very important concept, my dear children. Now apart from that, there is one more concept called as radical axis. Now what is this radical axis? Okay, so see here children, I have spoken to you something called as power of a point. There is one circle over here, there is one circle over here. From this point, I draw a tangent. This point I draw a tangent. Are these two lengths equal? No. Let us just call this circle as S is equal to 0. This circle as S dash is equal to 0. Now is this length is equal to this length? No. So I am not interested in this point. So I am not interested in this point. I will take this point. This length and this length are equal. I am interested in this point. Similarly, this length and this length of tangent from this point and this point is equal. I will take this point. This length and this length, I will take this point. Similarly on this side also, this and this length of tangent formula is what? Under root S11. So this I will collect. Similarly from this point I find length of tangent from here to here. I will collect this point. And if I join all these points, it will be a straight line. It will be a straight line. And that straight line is called radical axis. Now how do I define radical axis? Definition, right? You must be able to define radical axis. See here, the definition goes this way, right? Radical axis is the, join means locus, is the locus of all the points, the powers of which with respect to two given circles is equal. That is what? So this is equal to this. Length of tangent is also otherwise called as power. So this is equal to this. So when I join all these things, I will get a line. That line is called radical axis. Now this radical axis has got certain property, right? Now how do you find equation of radical axis? Equation of radical axis of two circles. Equation of radical axis of two circles, S is equal to 0 and S dash is equal to 0, is S minus S dash is equal to 0. Simply you subtract two circles from another, whatever equation you get, that will be a straight line, and that is nothing but your radical axis. And there is a note, warning also, right? This S is equal to 0 and S dash is equal to 0 should be in the same form. Same form means what? It should be in the standard form, x square plus y square. It's only then you can subtract. Alright. So that is very important. So that is the equation of radical axis. Now there is one more note also. If I join this radical axis will be always perpendicular. Radical axis is always perpendicular to the line joining centers of the circle. Radical axis is always perpendicular to the what? Line joining centers of the circle. Now these two are circles which are non-intersecting circles. Now if two circles are intersecting circles, right? Now I will write, if two circles are intersecting circles, the radical axis of intersecting circles is a common chord. Simply we will say find the equation of the common chord and two circles will be given to you. How will you find the equation of common chord? When two circles are intersecting, common chord is nothing but radical axis. And how do you find the equation of radical axis? S minus S dash is equal to 0 or S1 minus S2 is equal to 0. So when two circles are intersecting each other, the radical axis is nothing but a common chord. Alright. And if two circles are touching each other, radical axis is nothing but radical axis of two circles touching each other is a common tangent. Simply he will give you equations of two circles touching each other and he will ask you find the equation of common tangent, right? How do you find? Simply s minus s dash is equal to 0. So I want you to pause the video, copy the concept, and we will go for the leftover concept, and with that our concept of system of circles or our part 4 will come to a conclusion, right? Children, last topic, radical center. Now what is radical center? See, I take this two circles, I find the radical axis. Radical axis will be the perpendicular to line joining centers. I take another circle which is over here. For these two circles, I find the radical axis. Right? You can see that these two circles are intersecting. You know, this point of intersection is called radical center. How do I define radical center? Radical center is the point of intersection of, you may pause the video and copy down. Radical center is the point of intersection of radical axis of three circles. Radical center is the point of intersection of radical axis of three circles whose centers are non-collinear. Now why did I mention the word non-collinear? See what happens if these two are circles. If I take another circle here and find its radical axis, do you think these two lines will ever meet? No, because these centers were collinear, the radical axis will be parallel to each other, they won't meet. Hence, you must always have the three centers of the circles to be non-collinear. It's only that they meet. Alright, so that is the concept of radical center. You may get a 2 marks question, find the radical center. He will give you s is equal to 0, he will give you s dash is equal to 0, s double dash is equal to 0. You find s minus s dash is equal to 0. First radical axis, you find s dash minus s double dash is equal to 0. Second radical axis, again you solve first and second, what you get is a radical center. So that is how you will find the radical center. Now there is one more small note which is to be exercised by the student. Now let us say for these three circles, I get this as radical center. So if I take this center as radical center, from this center I apply power formula, power S11, right, to this circle, or I apply power formula to this circle, or apply power formula to this circle. To your surprise, this length will be equal to this length, will be equal to this length. And if I take that length as radius as root S11, and center if I take as radical center, if center you take, radius you take as root 11, and you construct an equation x minus a whole square plus y minus b whole square is equal to r square. Instead of what will you write? X minus radical center whole square plus y minus radical center means a or b, is equal to root s11 whole square. Whatever circle you are going to get, that circle is going to cut all the three circles orthogonally. A very, very important question, right? I repeat. If you take the center as radical center and the radius as under root S1, all power of the point to any circle, and construct a circle, then that circle is going to cut all the three circles orthogonally. So you will get in the examination, find the equation of a circle which is orthogonal to three given circles. What will you do? You find the radical center. After finding the radical center with the help of the same point, find under root S11. So you have center, you have radius, find the equation of the formula, find the equation of the circle with the formula given to you in the first part, first formula, and what you get is a circle. That circle is going to cut all the three circles orthogonally. So my dear children, I will take a break here because for your syllabus, whether it is a CBSE board or a state board, you are having problems related till this point only. Apart from that, there are other concepts called as coaxial system of circles. There is another called as limiting points of the circles. Now for those concepts, I shall make a separate video and you will get those video. Anyhow, those concepts will not be there for entrance examinations or board questions. If you are perfect till here, that is sufficient. So I want you to practice a lot, write a lot, and then do well. And don't forget to like our video and share our video, and always hit the like bell icon. Thank you, bye bye, and take care.